Climate change has been a hot topic in the media over the past 5 decades. Many negative effects to the environment have been discussed, including warming oceans, shrinking ice sheets, glacial retreat, decreased snow cover, sea level rise, declining Arctic sea ice, extreme events, and ocean acidification. Although there is a focus on environmental issues associated with climate change, there are many other consequences, most notably including economic ones.
The Earth gets energy in the form of sunlight. The Earth's surface absorbs some of this energy and therefore heats up. In order to cool down, the Earth gives off a different form of energy that is called infrared radiation. This radiation escapes the Earth into outer space, but greenhouse gases in the atmosphere absorb some of it, making the atmosphere warmer. As the atmosphere gets warmer, it makes the Earth's surface warmer too. The more greenhouse gases are emitted into the atmosphere, the more radiation will be absorbed, heating the planet as a consequence. Within the past 130 years, the global average temperature has increased 1.5 degrees Fahrenheit, with more than half of that increase occurring over only the past 35 years. Every one of the past 40 years has been warmer than the 20th century average. The 12 warmest years on record have all occurred since 1998. Climate change was first theorized in 1820 by French mathematician and physicist Joseph Fourier. Alexander Graham Bell theorized temperature rises resulting from the burning of fossil fuels in 1917. Lyndon B. Johnson warned of climate change in 1965, and George H.W. Bush formed the Intergovernmental Panel on Climate Change in 1992.
Charles Keeling was a scientist who showed rises in carbon dioxide levels in 1960. He conducted his experiments on a Hawaiian volcano called Mauna Loa. In this graph, it is depicted that carbon dioxide levels have been increasing over the past 50 years.
It has been found that there is over 95% probability that the current warming trend is caused by human activity since the mid-20th century. Roughly 97% of climate scientists agree with this view. Prominent scientific organizations have made official statements backing the science, indicating human behavior as the cause of climate change. These organizations include the American Association for the Advancement of Science, the American Chemical Society, the American Medical Association, the American Geophysical Union, the American Meteorological Society, and the Geological Society of America.
Human-made climate change has a specific fingerprint or signature that is observable by scientists. Compared to other carbon sources, carbon from fossil fuels behave differently. Scientists are able to tell whether the carbon in the atmosphere came from fossil fuels because the carbon particle is more negative. Using this information, scientists were able to tell that fossil fuel emissions are the largest contributor of CO2 concentrations since the pre-industrial era.
All right, so to kind of explain pollution from an economic standpoint, we're just going to use a really simple graph here. So this axis has price on it, this has quantity. This is just society's demand curve for a certain product, and this is the marginal cost curve for the firm producing the product. So the key here is in this marginal cost curve, they're only factoring their own cost of production in. So they're just looking at the supplies, the labor, the machinery needed to make the product. The problem is, a lot of times when companies do this, they forget that when they make something, it has a cost on society, most commonly pollution. So let's say that we have this curve right here, and this is the marginal social cost. So this is the cost curve that represents the cost to the producer and the cost to society also. The difference between these two curves is called your marginal external cost. So this is the difference. This is basically when the firm's producing and they're only looking at this curve, they're failing to account for the external cost they're putting on society. So if we were to look at a firm that's producing only looking at themselves and not at what they're doing to society, they're going to produce, the market will clear at this point, so they're going to produce this much of a certain good, and they're going to produce it at this price. But if they were to factor in the cost to society, the market would clear at this point. So as you can see here, when they only focus on their own cost, they produce too much of a good, so they should produce less, and they produce it at too low of a price, so it should cost more. And this area right here can be thought of as the total external cost. So this is the area where when the firm produces an item, they're still producing a cost to society, but it's being accounted for in the market. However, this difference right here, we'll use a different color marker. This area can be thought as your deadweight loss. So let's say that the company produced a pollutant when they made their product, and the pollutant was bad for the environment. This triangle right here is the deadweight loss, and this is all the pollution happening to society because the company is failing to account for their true cost of production. And if enough companies only look at their cost of production and not the socially optimal amounts that they should produce, this can result in major pollution problems and ultimately global warming.
Okay, so under regular command and control policy, which is what's normally instated by the government, each firm would be told to abate the same amount of units. So let's say that they're told to each abate 60 units. So I'll represent that here. As you can see, for each firm, the costs are very different for just abating those 60 units. So for the third firm, it's roughly $200 versus firm number 1 is only about $120. So this is a huge difference in costs. So another way that we can actually go about abating and cutting emissions is to instate a cap and trade system. So within a cap and trade system, there will be a certain level of emissions that are allowable for the entire industry, and this is set by the government. So let's say these are the permits right here. Okay. So there's a certain cap for all of emissions, and it is then up to the firms to decide how much they actually want to abate by being given a certain amount of permits per firm. They're then able to either sell those permits, keep them, or buy more permits. So you can imagine that for a firm that has a really low abatement cost, they're actually able to abate even more at a lower cost, and then they can profit from selling their permits at a higher price. So they're actually making profit on this. And for firm number 3, for example, they have a really high abatement cost. So instead of abating this amount, they're actually able to purchase permits for a lower price, so they're actually saving. So it's a really great economical model of how you can actually cut costs for firms, so it's not very expensive for them to cut emissions. And at the end of the day, the same amount of emissions are being cut from the environment. So in conclusion, with the cap and trade model, we're actually able to work with firms to still cut emissions to reach our carbon goals, but also they're able to make sure that they can still maximize their profits.
All right, so this is a graph showing different companies' marginal cost curves. So it's actually their marginal abatement cost curve. So each curve shows how much it costs to abate a unit of pollution. And abating a unit of pollution just means getting rid of that amount. So as quantity goes this way, as they abate more, it costs more to abate that. So if the government was to set a tax right here, it would make economic sense. If they were to set a tax right here, and the government was said, you should abate this much quantity for the optimal outcome, it would make sense for firm 1 to not pay the tax whatsoever and abate more. Firm 2 would abate up to here, but as their abatement cost rises, paying the tax is cheaper, so it would make more sense for them to just pay the tax. And firm 3 is the same as firm 2, but their costs are even higher. So they would abate to this point and then pay the tax as they move forward up the line. So if the tax is set correctly, this can actually result in the socially optimal amount of abatement.
As opposed to regular command and control policies, market-based strategies for reducing emissions are both more cost-effective and foster innovation. Using clean energy can not only help to reach carbon goals, but can also cut energy costs for companies. The firms may choose themselves how much they can afford to cut in emissions based on how easy and cost-effective it will be for them to do so. The firms can still operate to maximize profit by finding solutions and technology that helps them cut costs as much as possible.
The clean energy industry generates hundreds of billions in economic activity, and it is expected to continue to grow rapidly in the coming years. There is tremendous economic opportunity for the countries that invent, manufacture, and export clean energy technologies. Solar, hydroelectric, wind, bioenergy, and nuclear are all sectors that have already seen investment and development in the past and are also renewable. Solar and wind produce no byproducts and simply harness the power of the earth to create clean and renewable energy. There are an abundance of biofuels with ample opportunity to expand upon the efficient ones, which produce very little carbon after combustion. Nuclear produces no greenhouse gases, is efficient, and has also seen investment. However, it does produce nuclear waste.
Some argue that cutting down on emissions can affect economic growth, but recent history has proved otherwise. Between 2014 and 2015, the global economy grew by 6.5%, but carbon dioxide emissions from energy generation and transport remained flat. As a matter of fact, CO2 emissions in Europe, the United States, and even China have been falling. It is possible to continue growing the economy while cutting greenhouse gases, as has been shown here. As global mean temperatures increase, value of damage has been calculated across multiple areas such as agriculture, crime, coastal storms, energy, human mortality, and labor. It was found that the cost would be roughly 1.2% of gross domestic product per increase in temperature of 1 degree Celsius.
Renewables have gotten much more efficient and cheaper. Wind and solar costs have dropped 60% since 2009, and they are projected to reduce 40% in the next 10 years. This is expected to have a deflationary effect on coal-produced electricity prices. Goldman Sachs forecasts that by 2020, renewables will cost less than the current power price. If this is the case, renewable energy will not need subsidies to function, and they can work just like industries already in place. In doing so, they can help to save the earth and reduce our carbon footprint.